Hi guys, today what we're going to learn about is permutations. Last lesson we learned about factorial notation, where factorial notation is useful for writing the number of possible outcomes when arranging all objects in order without replacement. However, it becomes slightly more complex when we arrange only some of the objects in order without replacement. A permutation describes an arrangement or ordered selection of R objects from a total of N objects without replacement or repetition. The permutation NPR is a number of ways of making ordered selections of R objects from a total of N objects, where NPR equals N times N minus 1 times N minus 2 times N minus 3 times so on until we have R times. So NPR equals N times N minus 1 times N minus 2 times N minus 3 times etc. until we have times N minus R plus 1. We can also write NPR to be equal to N factorial all over N minus R factorial. A special case of this is NPN, which is N just equal to N factorial. For our first example, we want to find the number of arrangements of 3 digits that can be formed using the digits 0 to 9 if each digit can only be used once. So we could use this doing our counting techniques. So we could think about it as having our first digit to go in the first box, our second digit in the third box, and our third digit in our third box. And because we have from 0 to 9, we have a total of N equals 10 objects that we can put in. So in our first box, we could put 10 numbers. Then because we have used one of the numbers, we can't replace it. So that means we only have 9 digits left. And then because we've used 2 digits, we only have 8 digits left. So using counting techniques, how we would solve this is we'd go our total permutation equals 10 times 9 times 8, which equals a total of 720. However, using permutations, so NPR, we can say that our N equals 10 and our R is how many we're picking, so how many digits we want to put into places, and so we have 3 digits. So we can do this on a calculator. So to get a permutation on the calculator, what we have to do is use shift times. So we use shift times. So what we're going to do is, to use our calculator, what we do is we write 10, get our P symbol 3, and on our calculator we go 10 shift times 3 equals 720. And as you can see, our counting techniques way and our using our permutations is exactly the same. Example 2, we want to evaluate how many 3-digit numbers greater than 700 can be formed. So using counting techniques, when we think about the first digit, it must be 7, 8 or 9. So if I draw my boxes up again, I'll do them off to the side. Our first digit can only be 7, 8 or 9. So we are going to put that we can only have 3 digits in there. But the second digit can be any of the remaining 9 digits because we have our 10 digits that we're playing with. So we write our 9 in there, and then our third digit can be any of the remaining 8 digits. So using counting techniques, our total arrangement would be 3 times 9 times 8. And when we put that into our calculator, we get 216. But if we use permutations, there are 3 ways to get the first digit. So what we do is we just write our 3 times, and then the possible arrangement of the remaining 2 digits is 9p2. So we write our 9p2. So when we put this into our calculator, we keep our 3 as 3, and then to calculate 9p2 is put that in our calculator using our shift times, we get 72, and so 3 times 72 equals our 216. And as you can see, they're exactly the same for our counting techniques and our using permutations. However, sometimes permutations can have restrictions, and some examples need very careful counting. So sometimes you can use permutations to solve these problems. Other times you can use factorials. So for example 3, for 3a, we have in how many ways can 8 people sit around a circular table? And as you can see here, I have a diagram and we have our 8 spots that people can sit at. So we need to, when we talk about sitting people around a circular table, we need to have a fixed spot. So I'm going to say that this person here is my fixed spot. So we let the first person sit anywhere. So I'm saying my first person is going to sit at that X around the table. So then we only need to, once we put them down, we only need to arrange the other people. So we write this as 8 factorial because we have 8 spots divided by 8. Because that first person has 8 places of choosing. So we divide that by 8. So when we do this, we have 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by our 8. And so when we do this, our 8's cancel out, and this leaves us with 7 factorial. Okay, so we can also write this as n minus 1 factorial, which would equal 8 minus 1 factorial in our case here. So that means our answer is going to be for how many ways can 8 people sit around a circular table. It's going to be 7 factorial, which equals 5,040. For example B, 3b, if seating is random, find the probability that 3 particular people will sit together. So 3 people can sit anywhere around the round table if they sit together. So we count them together as 1. So I'm going to count these 3 people as 1. And so they can be together as 3 factorial ways. So the way that they can sit in their little factorial, in their little cluster, is 3 factorial ways. Because anyone can sit at this table, at this seat, anyone can sit at the second seat, and anyone can sit in the third seat, and they can swap around. They don't have to be in a fixed spot. So to work out the total arrangements, what we do is we now have 1, 2, 3, 4, 5, 6 places where people can sit. So we do n minus 1 factorial, so 6 minus 1 factorial times our 3 factorial ways. So when we calculate that, 6 minus 1 is our 5 factorial multiplied by our 3 factorial, and 5 factorial times 3 factorial is 720. But the key point in the question was that it was asking us find the probability. So we have not answered the question here with our total arrangements. We need to find the probability that those 3 sit together. So what we do is we say that if they sit together, they have 720 different ways. And we divide that by in how many ways 8 people can sit around a circular table, which is what we did in part A. And we found the answer to be 5,040. So we divide this by 5,040. So 720 divided by 5,040 is 1 over 7. In example 4, we want to know how many ways can we rearrange the word boots. So we write this as how many letters we have in the word boots. So we have 5 letters divided by how many repeated letters we have. And in the word boots, we have 2 O's. So we have 2 repeated letters. So we write this as 5 factorial divided by 2 factorial. So this is the same as writing 5 times 4 times 3 times 2 times 1 divided by 2 times 1. In where our 2 times 1 and our 2 times 1 cancel out, leaving us with 5 times 4 times 3. So where 5 times 4 times 3, or 5 factorial divided by 2 factorial, equals 60. So in how many ways we can rearrange the word boots is 60 total ways. So permutations can also involve repeated objects. The number of different ways of arranging n objects in which A of the objects are of one kind, B of the objects are of another kind, and C of the objects of another kind, and so on, is given by the formula n factorial divided by A factorial times B factorial times C factorial times and so on, where A plus B plus C and so on is less than or equal to n. So for our example here, we have how many 9-letter words can be made of the word isosceles. So isosceles has a total of 9 letters and 3 S's and 2 E's. So therefore, our answer in this case is that we have, for n, it would be, therefore our n would equal 9, our A would equal 3, and our B will equal 2. So our answer is going to be 9 factorial divided by 3 factorial times 2 factorial, which equals, when we place this into our calculator, 30,240. So there are 30,240 ways and 9-letter words can be made from the word isosceles. If you are following the Margaret Groves Maths in Focus textbook, you should now complete exercise 304.